Okay, we continue the mesh analysis with current source. So when we have some current source in the mesh analysis, we don't need to calculate for this mesh current, right? If we denote I1 and then I2, we know directly that I2 equal to minus Is, right? I2 is Is in the opposite direction, right? It's minus Is. Or Is minus I2 is Is, right? Minus I2 is Is. So we know this current, right? So if we construct I1, mesh I1, this is plus, this is plus, minus, plus, minus. So keep this systematic plus, minus, and then minus. Right? So KVL at node 1, Vs minus R1 into I1 minus R2 into I1 minus I2, right, equal to 0. But in this case, we know I2, that is the negative Is, right? We know this current. So we don't need to solve for I2, and we can use Vs minus R1 into I1 minus R2 into I1 minus I2 is plus Is equal to 0 here, right? This is I1 and this is Is in the same direction, so it's plus together, right? In this case, we know, if we know Vs, we know R. And then if we know Is, we just solve for I1 in a single equation, right? We just solve for I1 in a single equation. Solve I1. Okay, just rearrange your equation, right? Or just substitute the value we know and we solve for I1. So one equation, one unknown, right? Okay. Yeah. So we solve only n minus m. So if we have m current source in the circuit, the equation remain n minus m, right? Okay, let's see this example, right? So we have I1 that we know is I. So we don't need to solve for I1 in fact, right? Because we know I1 is I, is 0.5 amp already. So we remain only two unknown to solve for. Right? Okay, let's see how to solve it step by step. Yeah. So for the first node, if you just keep systematic, okay, this should be plus. The base one we don't need to solve, right? We know it's I1 is I, and next number 2, which is I2 plus minus minus here, right? And then plus flowing out from the element positive, negative, and then negative. Okay. Then we get R2 into I2 minus I1 plus R3 into I2 minus I3 and then plus V is 0, right? Then we substitute the known value, right? The known value R2 is 8, right? 8 into I2 minus I1. I1 then 0.5 plus R3 is 6 I2 minus I3 plus 6 volt, right? 6 volt equal to 0. This is equation 1, right? You just rearrange this because we have two unknown in this equation, I2 and I3. Okay. Then okay, I maybe we try step by step. Hi2 minus 4 plus 6I2 minus 6I3, right? Plus 6 equal to 0, right? I2 I1 2 6 plus 6 equal to 0, right? Plus minus plus plus. I2 and I2 and I2 should be 14 I2 minus 6 I3 is 2, is minus 2. I don't know why it's different. Anything wrong? Minus R2, right? Minus R3. I2 minus I3. Right? 6. Oh, minus here. Sorry. That's why. Yes. It should be minus here, right? Okay. Then minus and plus here, right? And this is minus also. Sorry. Minus here and minus here. This is minus, this become plus, right? Minus, and then this is minus and this is plus here. Okay, equal to 10, right? So we get the same equation now. Yeah. Right. Then this is mesh 2, right? Mesh 2, and now mesh 3. Mesh 3 here. Again, plus minus plus minus plus minus. Okay, then minus all, right? Okay, minus all, minus all. Oh, minus R1 into I3 minus I1 minus R4 into I3 minus R3 into I3 minus I2 equal to 0, right? Now R1 minus 3, I3 minus I1 is 0.5, R4 4, R3 6, right? 6. I3 minus I2 equal to 0. Minus 6 I2, 6 I2, 6 I2, I3 is minus 3, minus 4, minus 6 is 13, minus 13 I3 equal to, this is minus 3 into 0.5, 1.5, right? It's the same equation now, okay, right? We get the same equation. So we solve these two equations, we get I2 and I3. So if we would like to know, for example, further parameter, how much for V across R2, what is V across R2? It should be, so first we find out I flows to R2, R4, or R2, how much? The current flow across R2, this direction, okay, in this. So if we take this direction as positive, so it would be 0.5 minus 0.95, right? 0.95 is equal to minus 0.45 amp, right? The current flow across R2 is 0.5. It's I1 minus I2, right? I1 minus I2 in this direction. So we get negative value. So in fact, the current flow in upper direction, right? Yeah. And the voltage would be is minus 0.5 into R2 is into 8, right? Boom, like this. Okay. So if we denote our positive side in upper direction, if current across R2 like this, so current flow to R2, this would be I2 minus I1. Now it's 0.95 minus 0.5 is positive 0.45 amp. So the direction is correct, right? So it's in the positive direction. So it depends on your definition, you define the direction. And if you get the negative side, it means you get the opposite direction, right, of the current and voltage. Okay. So you now, after you get I2 and I3, you can find out all the voltage across the resistor, right? All voltage across the resistor. You can also obtain the voltage across the current source also. Because we don't know how much the voltage across the current source. After that, we can get the voltage across the current source. How much? So you, by taking KVL, right? If we take KVL, you get the voltage across the current source. Okay. Another example, right? Okay. So in this example, Vs is 10 volt, Is is 2 amp, R1 is 5 ohm and R2 2 ohm, R3 is 4 ohm. Okay. So I2 is Is, right? I2 equal to 2 amp here. Okay. So in this case, we would like to find out Vx, right? Vx here. So Vx, we can obtain Vx by KVL with this loop. KVL, right? So Vx. So Vx is, if we take KVL this loop, this is plus, this is minus, this is plus, this is minus, and this is minus, right? Minus Vx here in this polarity. Then minus R3 into minus R3 into I2 minus I1 minus R2 into I2 minus Vx equal to 0, right here. Same equation here. So if we know I2, I1, I2, we get Vx, right? But we know only I2 now, so we try to solve for I1 first. If we know I1, then we can know Vx, right? Here, Vx, we can just rearrange the equation, right? But right now we know only I2, which is 2 amp here. Okay. So then take KVL mesh 1. KVL mesh 1. Then this is negative positive, this is plus, minus here, plus, minus here. So for KVL mesh 1, plus, minus, right? We will get 10 volt, right? Vs. Okay, I think I can substitute directly. Vs is 10 volt minus 5 into I1 minus 4 into I1 minus I2. I1 minus I2 equal to 0. But in this case, I2 is 2 amp, right? So I just substitute 2 amp here. 2 amp. Okay. Then I just solve for I1 here. We can get I1. So we can solve for I1. Then we substitute I1. We can get Vx, right? So solve for I1 first, so we can know the voltage across the current source later by KVL. Okay, this is will be your homework. How many homework that do you have now? 2. 5?
No.
No.
1.
2 homework. This is the second one.
Yeah.
This is the second homework, right? So this is should be homework number 2, right? Okay. This is your homework number 2. And you submit it. Next week? Okay. Next Thursday, okay? But next Thursday I am not around. The deadline is in the e-learning system, okay? You submit next week. Okay. Number 2. Okay, I stop recording here and because it will separate the next topic.